Afternoon, this is the Pie in the Sky presentation. I'm Dave Akerman. My day job is programming. My evening job is being a minder and a publicist for Beveridge, who's sitting up there. So that picture was taken from the ISS. To get to the ISS on the space shuttle, £300 million. In there you can see the thin blue line of the atmosphere, you can see blackness of space, you can see a nice big cloud. In that picture you can see the same thing. The blue line of the atmosphere, blackness of space. Slightly smaller budget. If you started from scratch you could probably do this for £300. Per launch is probably about 200. And to give you an idea where we go, the space station orbits at 400 kilometres. That's real space, proper space. And even then, they have to fire their rockets occasionally to maintain orbit. Space officially starts at 100 kilometres, just a round number. And we get to about 40, maybe 44 kilometres, I think, is the record. Babbage has got to 41, 150, something like that. At that point there, like I say, you see the blackness of space, you see that for maybe 20 kilometres upwards. You're way, way above jet aircraft. So next time you fly in a 747 at 39,000 feet, you can go, not very high. And typically with a balloon, it's not always the case, but they go up at a fair rate. Actually, when you launch one for the first time, it's amazing how quickly they go up. People are used to seeing hot air balloons just drift off the ground. That vertical rate is about 10 miles an hour. It's about the same as a jet airliner, vertically. Obviously, horizontally, it's not quite that fast, except for the first Babbage jump, where it was quite quick. Eventually, it runs out of, the latex gets so large, it stretches so much, it can't maintain integrity, and it bursts. And then all hell breaks loose as the thing drops at maybe 200, 300, 400 miles an hour. So that poor thing there is being at that sort of speed. Eventually it lands under a parachute, obviously, at about the same speed it set off at. So if you want to do this, what do you need? Well, the first thing you need, obviously, is a balloon, which is going to fly in any moment now. Yep, there we go. It's a standard weather balloon as used by Met offices the world over. Next, some gas, that's helium. Helium is a limited resource, it's running out, it's expensive, it's doubled in price in the last 10 years. I use hydrogen, which is a third of the price, and that will improve. Goes a bit higher, maybe 500 metres or so, and it's got that fun factor. You definitely don't need a parachute, don't walk through that one. Camera of some sort. Obviously nowadays they use the pipe, but originally use a compact camera program to take a photograph every few seconds. A tracker, that's one you can just buy that tracks for you using a satellite system. And insulation. Here's the box you can buy. I think it's about £2, £2.50 in Hobbycraft. And it's just that standard white foam insulation. Tape to stick it all together, though I tend to use, the traditional Halo box would be a large box made of foam with gaffer tape all the way around. The gaffer tape actually weighs more than the box does. I like to use kind of more artistic shapes. And some string to tie all these things together. So that's the list there. I have to mention permission to launch. Don't go and do this without permission because it will give the whole hobby a bad name and possibly get banned or something ridiculous. And the CAA provide that. At the bottom, landing prediction. The general idea with these things is to fly it, get your photos and get the thing back. So you need to know where it's going to land, which if it's on land, it's okay. If it's in the middle of London, that's probably not so good. If it's at the end of Stansted Airport runway, that's not good either. Yes, that happened recently to me. And obviously the North Sea would be bad as well, and yes, that happened to me. Okay, so I showed earlier this kind of built-in tracker thing that you could just buy. You can buy these cheap trackers. It's basically a mobile phone without a screen. And these things you attach to cats, dogs, grannies that go walkies, and it tells you where they are. Lots of people use these on balloons and they do not work. There's about 50% success rate in my experience, and they're a very good way of losing the camera on your photographs. The next step up for an HV as well is a spot tracker, which is the one I showed you. This works on a satellite network, so it doesn't rely on the mobile phone signal. But they still stop working about 18 kilometres. So you launch this thing, gets to 18 kilometres, and then you don't know where it is anymore. You have to wait for it to come back down through that level before you find it. If it lands upside down, the signal's too weak to the satellite system, it doesn't know where it is, and it won't tell you. So, and those cost 300 quid. So now you lost 300 quid. So what everyone in the UK does, and most other central countries, use radio system. This is a license-free radio, because that's all we can use in the UK. Other countries, it's different. And this transmits all through the flight, including above 18 kilometres. So every 15-20 seconds, roughly, it sends a message over a radio network and says, this is where I am. And then you can follow it for the whole flight. So if you launched with too little gas and it went up too slowly, it won't follow your prediction, but you still know where it is. But then you know if to go a different place to pick it up, or to wave goodbye if it's going to Europe or something. So, I got into this hobby through photography. I saw a YouTube video on the photo forum, and when it comes in there, yeah, there's a famous photographer. Obviously it's got space, so there's a spaceman, so I now picked up the theme by now. Science, if you want to measure pressure, temperature. I'm looking over that direction. Computing. There's electronics and software.
Is that Jimmy Hill on that?
I'm not quite sure.
Jimmy Hill.
Weather forecasting. Told you. You know, you need to watch the weather. In fact, I had one flight where the prediction said the weather was going to change, and I had a tweet from someone who said, not from where I'm sitting. I thought, good, how are you? And he was a BBC weather forecaster. It turned out I was right and he was wrong anyway. So. And travel. So I've been to Europe chasing these things and launched them in other countries, and just travelling around the UK to random places to pick these up. There's no more. So this is how our tracking system works. So I have a radio transmitter. I can show you one. In fact, he's got one sticking out of his bum.
We pulled that
I've got bullet jokes planned, obviously, but not the, yeah. So there's a little radio transmitter in the bottom with an aerial here. This is called ground plane. It's part of the aerial, essentially, and a tracker and a GPS. So that transmits down to the ground. Even though it's a low power, that's a line of sight signal. So if the balloon's in the air and there's nothing between you and the balloon, you can receive it. The record, I think, is 800 kilometres for a signal that's 1/100th of the power of a mobile phone signal. Almost nothing. Laptop to decode, and then this finds a map. I've got a car there because chase cars have GPS on them, and that uploads to the map via 3G. So to make a tracker, you need a computer of some sort. That's quite a nice one, if you've heard of it. I would recommend a micro SD card. You don't want a regular SD card flapping at the end. Babbage's one actually bends, so we've got kernel error messages over the radio on the way down. GPS receiver, my friend here sells those. I'll give you a link later. Camera, radio transmitter, he sells them as well. Batteries, I use Energizer lithiums because they're spec to -40 and nothing else will work. And that's a little switching regulator. And some sort of board to cycle together. And essentially how that works, I'm looking at the time, it's not, I can talk for quite a while. Essentially what happens is the GPS sends a message which has got, if you can see in there, time, latitude, longitude, altitude. So it's essentially everything the balloon needs to know to tell you where it is. It goes into the processor, and then it gets retransmitted essentially out of the radio at the bottom. Obviously you can do more, you can put temperature sensors, pressure, anything else. Okay? And it's physically wired like so. So the transmitter gets wired to the serial port, because it's actually serial data we send down. So the easiest way on Pi is to connect it to there. The GPS is normally serial, but because we're using a serial already, I've got an I2C one. I2C and the GPS don't work together because there's a hardware limitation on the Pi. So that's done in software. So there's a software I2C driver. That's the data that gets sent, which on some other processor like an Arduino, you'd actually write the ones and zeros with the timing. But because it's ordinary RS-232 serial data, we just send it out of the UART. There's a board that Anthony here made up before. Come on, someone must see the background. Thank you. And there you see, there's the radio, U-blocks, GPS, there's a temperature sensor, and that's basically it. So there's very little electronics to add to a Pi to make a tracker. Okay, we're going to do a demo now, which is, there's a picture of the data being received. Those two lines are two frequencies. It's a FM, like your FM radio, two frequency modulators. So the two frequencies are the zeros and ones in the data. So, yeah. And that is this little transmitter here. That's an AVR. It's a very simple transmitter, a very simple tracker rather. And if we were to walk down the road with that, then those longitude latitude numbers would change. And it would walk along the back. So that's where we are now, actually. So you knew that. The GPS is in flight mode, so it still works above 18 kilometres. And there's more kind of jitter or noise on the 2D position in that mode, which is why it thinks we've been running around, but obviously it hasn't. And those messages come through every 15-20 seconds, so you get updates on the output at that period.
Yes.
Excellent. Okay. So to choose a tracker, that one there's an AVR, and up until the Pi came out, everyone used AVRs and PICs. So very basic processors. Almost any processor with memory will do the job. And what you need from one is lightweight, because the lighter it is, the higher your balloon goes. Little power, because more power means more batteries, which means heavier, which means it doesn't go as high. Work when cold, we're looking at temperatures minus 60 outside the box. Physically robust, when it lands, it will hit 10, 20 miles an hour if the parachute didn't work properly. And also when the balloon bursts, the thing will rotate a lot. One person flew with a breadboard circuit. I can tell you what I think of that idea. The thing would just fall apart. And tested reliable software. This map is visible to all the other people in the hobby, and it's a bit embarrassing when you hit the meridian and your balloon jumps to somewhere else. So compared to a Pi, an Arduino, for example, is from what I've said so far, is a much better option. It's lighter, less power, simpler, more robust, hasn't got an SD card stuck at the back, but it can't really drive a camera. A camera on an Arduino is 50 quid, rubbish quality, it takes a week to program. With a Pi, the Pi camera is much cheaper, much better quality, and you can get it going in hours. And quickly, if you do use a model, use a Pi, use a Model A because it's a third of the power. And I won't go through the list. Have a look at the bottom of that. You can make a good tracker with a Pi. So what a Pi gives you on top of an Arduino is the images. This is SSDV, slow scan digital video, and it basically takes a JPEG and cuts it up into small chunks. If you lose one chunk, you've lost the whole image, which if you sent a JPEG, you would lose the whole thing. You can send reasonable size images, maybe 800 by 500 pixels, which doesn't sound that high definition, but you're photographing clouds, which is fluffy, through an atmosphere which blurs at the ground anyway, so it's plenty. On the Pi, what I do is I take an image every 15 seconds. It takes about 5 minutes to transmit the image. So during that time, I've taken maybe another 10 or 20 images. So I have an algorithm which chooses the best image. Now, this could be something that looks for that kind of thing, with a bit of black, bit of... you could do proper image recognition. All I do is go for the largest file. But whatever you do, score the images and send the best one, because you want to ignore any images which are just that. So the thing swings round in the air and it will take photographs of the blackness of space. That would be a 0. So there's a nice image, a bit more black than I'd like, maybe a 3 out of 10. And that would be an 11. Okay, so we'll do a demo now. My colleague here has a payload I put together yesterday. And is that received to you?
So I don't think you'd leave it. You tune in.
Oh, okay. So that's the data from that one, just so you're aware. That's the data from that little tracker there. Followed by the right, and that was at 50 baud, so that's 50 bits per second. This one is 600. So it's 8 times quicker, which we need for the images, otherwise one full-size image, even at 600, takes 12 hours. And the flight's only 2. So I'll just set this up quickly. So I'm just choosing 600 version of software. So you may think, Dave, you've not tuned it in right because it's garbage, but that's actually the JPEG data, or the image data.
Is it 8 bits there?
Sorry?
It's 8 bits.
It's 8 bits. Oh, thank you. He's right, it is rubbish. Huh? 1 million, that's it.
Yeah, 1 minute.
Okay, so now it's, if you see that, it said, just behind it said decoding, and that's an image taken on there. Ah, good. Where's Ben?
Downstairs.
He's gone downstairs.
When you got the Pi instead as a tracker instead of an Arduino, you've got all this extra power. Why not use it? So it's got limits on there. So when you receive the image, you can download, image magic I used, and it can process your picture for you. So that's what good timing. And it could do anything. It could put it could put logos on or anything you like. Yeah. Which you can try that on an Arduino. It's just no chance. It's something important, isn't it? Yeah. That's the one there.
Oh, sorry.
I just have to just stop.
Well, you can do a raffle.
Okay. Okay. I'll show you a couple of trackers I've observed. That's the TARDIS one, which is at Pi Towers at the moment. That had a 3G backup, and which you can see there. And if I go on. So this had a webcam stuck out on an arm, looking back at the TARDIS. The TARDIS had the Pi inside. And after it landed, it reconnected to 3G for us. It was all programmed, and started streaming video of us two, actually. X-Files, I know, but how do I pick it up? And then, again, you couldn't do that on an Arduino. It's impossible. So, we're really not using a tiny fraction of the processor power of the Pi to do this kind of thing. So that will do for that. That's oh yes. That's Babbage before the work. All the original astronauts had what was called the right stuff, and he of course had the right stuffing. He has a bit less of it now. So he went on the weight loss procedure. And this, if you haven't seen it, you don't know the person in the world. Is what happened when he did Austria beat Felix's record. And the one last thing, just half a minute. One thing we try and do in the hobby is keep the people watching and track, helping involved. And so we have a video stream running from the car or from the launch. And my colleague here, this is his idea, and this is why I made him look stupid, was to have a cam, actually a point of view camera, videoing when I'm yes, there you go.
Right, I'm off the toilet now, everybody.
So people can comment on the quality of my knots, that kind of thing. And that's just turn it on and go. It's got batteries in there, just turn it on, it connects to the internet and uploads. That's it.